properties of acids and bases and some of the indicators are what we're going to go through today. So, properties of acids. We know that they're going to have a pH less than 7 in their aqueous solutions. When we dissolve an acid in water, the pH is less than 7. We know that one. That's easy for us. These next 3 things are something you're going to want to memorize. Memorize, memorize, memorize. You also want to memorize the pH is less than 7, and you kind of already have that memorized, hopefully. But the next 3 are going to be a way for you to predict if I took an acid with some other chemical in my stockroom, what would happen. So we're going to make some predictions. So starting out, if we react an acid with a metal, they're going to form hydrogen gas and the leftover salt and a salt. So my first example, I have hydrochloric acid reacting with lithium, an alkali metal, gives me hydrogen gas. So I've got diatomic, remember that one, it's going to always be diatomic when on its own. Diatomic hydrogen gas. And then I have to look at the leftover stuff. Remember that we list metal and then the non-metal. And we have to look at charges. Because a salt is just an ionic substance. So just double checking that I did it right here. Lithium, an alkali metal, has a 1+ charge. Chlorine, halogen, has a 1 negative charge. When I crisscross those, sure enough, I get LiCl. Let's pick a different element. Let's pick aluminum. And I'm going to react it this time with sulfuric acid, H2SO4. What's the first thing I can write down without really having to think? Yeah, 2H2, or just H2. 2 hydrogens, that's what I was trying to say. So, I got that part done. Always going to form hydrogen gas. Now, I need to look at what's left over. So I've got aluminum, and I've got the sulfate ion. Oops. So plus, what's the charge of aluminum? 3+, absolutely. And sulfate? 2-, absolutely. Which even if I didn't have it memorized, I could look at this subscript here. There's a 2 there. That came from the sulfate ion. Didn't come from the hydrogen. It came from the sulfate ion. So then I crisscross those. I get Al2. Then in parentheses SO4, parentheses 3. Remembering way back, we put those parentheses around it because the entire group, there has to be 3 of that entire group. Go ahead, balance it. Because once we get that all set up, we need to balance. Show me with your fingers what number I put in front of the Al. Nice, a 2. And with your fingers, what number do I put in front of sulfuric acid? Absolutely, I need a 3. Show me again using your fingers what goes in front of the H2. I do need to put a 3 in front of it. Do I put anything in front of the Al2SO4 3? No, lots of heads shaken. No, good. So now I've got it balanced. Now I can move on to the next problem. What questions do you have before we move on to the second type that we need to memorize? Our ways of predicting products. Okay. So a second type of reaction, I could react an acid with a base. We know that that's a neutralization reaction. Because I'm neutralizing the acid with the base, or the base with the acid if we're starting with the other one. Neutralization reaction. So when I take an acid, which that's right here, HCl, and a base, NaOH, and I put the acid and the base together, now notice I'm not doing the displacement with water and identifying which one's becoming an acid. I'm actually taking something that's already an acid, an aqueous solution of HCl, and an aqueous solution of a base, NaOH, and putting them together. And I am always going to get a salt and water. Bless you. The salt, again, just to remind you, is just an ionic substance. So in this instance, I can write down the H2O right away. That takes care of the OH that I have there, the H that I have there. Then I look at what's left. I always put the metal first, the non-metal second. I look at the charges. Na was a 1+, Cl a 1-, and that's how I got my NaCl. And that one's already balanced. So we can write a note to ourselves, already balanced. Let's do another example of that. So let's take some calcium hydroxide. Ca has what charge? Show me with your fingers. Yeah, it's 2+ because it's in the second column. It's an alkali earth metal. And this is going to be my base, so it's with an OH, which is always a 1-. So that I would write as Ca parentheses OH parentheses 2. We do, because if I just put it, say CaOH 2, the 2 is only going to the hydrogen. I suppose you could. It might get confusing for somebody who doesn't realize that that means we have an hydroxide there. But theoretically, yes, you could. Okay, this is aqueous, dissolved in water, so I'm just going to put that there. We've already done that whole water thing, identifying which one's an acid and a base from the Bronsted-Lowry. We know this one's a base. CaOH2, and let's react it with some phosphoric acid. So hydrogen is a 1+, and then the phosphate ion, show me with your fingers what the charge of the phosphate ion is. Negative, of course. Yeah, it is 3-. So H3PO4, and again that's aqueous. So base plus acid, I'll be right with you, Maggie, gives me water and a salt. Okay, Maggie. Not for this one because there's no element, or there's no number coming behind it because the hydrogen atom only has 1 proton. Good question. Okay, since I know water is going to be one of my products, I'm just going to write that right away. So that water is coming from the H3 there and the OH2 there. So that's how I get my water. The leftover stuff, the calcium and the phosphate, is what I need to look at for my salt. So I'm going to say calcium, we did it up here, is a 2+ charge. Since it's a 2+ charge there, it's still a 2+ charge over here. Phosphate, same deal. PO4, 3 negative. And then I crisscross. Either nod or shake your head no. Do I need to put parentheses around the phosphate for this one?
Yeah.
Yeah. Good. Good, good, good. Lots of nodding. So, my salt is going to be Ca3 parentheses PO4 parentheses 2. Water, we're going to, sorry, I forgot my little L for liquid, and Ca3PO4 2 is going to be dissolved in that water, so aqueous. Go ahead, balance it. Remember when you're figuring out the coefficient for water to look at the fact that you have hydrogens in both locations. So show me with your fingers what number I will put in front of the calcium hydroxide. Nice. Cool. 3. 3 CaOH2s. Okay, show me with your fingers what goes in front of the phosphoric acid. Nice, a 2. And then finally, show me with your fingers what will go in front of the H2O. Awesome, lots of 6s. Cool. So we've done 2 types of things that acids can react with so far. We've got one more class of compounds. What questions do you have on acid-base reactions before we get to our last class of compounds? Okie dokie. So finally, we can react either a metal carbonate or a hydrogen carbonate, and we will form salt, water, and carbon dioxide. So my example here, hydrochloric acid plus zinc carbonate. So in this one, I have a metal carbonate, not hydrogen carbonate. And I form my salt, which is my ionic compound, ZnCl2, plus water and carbon dioxide. Go ahead, Natalie.
Where is the H2O
H from part of the hydrogen and part of the carbonate ion. Yep. Good, good, good. Yep.
Is every acid-base reaction going to have
Every acid base will definitely have water as one of the products. Good. Let's look at an example of this last one. So this time, let's use calcium carbonate What's the charge of calcium? 2 plus. Good. And carbonate? 2 negative. So CaCO3 plus, let's say nitric acid. So hydrogen, which is O1 plus, with the nitrate ion, NO3. What's the charge of nitrate? Not 2. 1, yeah. 1 negative. So calcium carbonate and nitric acid, HNO3. Going to react. The 2 I can write down right away, water and carbon dioxide. Then I can figure out my salt. So this whole carbonate part is taken care of. That whole hydrogen part is taken care of. What I am left with is the calcium and the nitrate. So I look at my charges, Ca 2 plus, NO3 1 negative. When I crisscross those, I have Ca in parentheses, NO3 parentheses 2. Then all I have to do is balance it. Go ahead and balance it out on your sheet. Show me with your fingers how many of the compounds I need to write a number in front of. Yeah, there's just one of them. So the nitrate ion, NO3, I have 2 on my product side, only 1 on my reactant side. So I'm going to put a 2 in front of my nitric acid. Then I'll check my other things. I've got 1 calcium on my reactant side, 1 calcium on my product side. 1 carbon on my reactant side, 1 carbon on my product side. 3 oxygens on my reactant side. I have 3 oxygens that are not part of the nitrate ion on my product side. I've got 1 here plus 2 there, that's 3. And then I take a look at my hydrogen. I have 2 hydrogen because 2 times the 1 hydrogen that's there. And sure enough, I've got 2 there. Go ahead, Haley.
Was the first equation that we did balanced?
It should have been. It should have been. If it wasn't, you can let me know. It should have been. Okay. Bases. We know the pH is greater than 7. And this one we've already written down. Bases react with acids to form salt and water. We even wrote that equation down. So indicators are the last thing we need to talk about. Indicators behave in a consistent manner to tell us whether something is acidic or basic. So they're going to change in predictable ways to show whether the aqueous solution is acidic or basic. Some of the most common ones: blue litmus paper, red litmus paper. pH paper is not listed on here. That's a common one as well. Phenolphthalein, methyl orange, and red cabbage juice. So you could make your own indicator at home by taking some cabbage and some water, boiling them together, straining out the cellulose. You would have an indicator at home. It's kind of stinky though, which is why we are not going to do it here. So what you should have seen in your take-home lab that we mostly didn't is that blue litmus paper, the acids are going to turn red. Red litmus paper, the bases are going to turn blue. Turn it blue. For the blue litmus paper, if we put it in a base, it's just going to stay blue. Red litmus paper, if we put it in an acid, it's just going to stay red. Phenolphthalein, not the pH paper, but phenolphthalein, the bases are going to turn pink. Acids remain colorless. We've seen that many times with our titration labs. Phenolphthalein remains colorless in acids.